Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be learning about bagging classifier. So what is it? Bagging, short for bootstrap aggregating, is a technique used in machine learning to improve the accuracy and stability of a classifier. The basic idea behind bagging classifier is to create multiple different versions of a classifier and then combine their prediction to make a final decision. I'll go with the theory, and I want you to just look at this diagram. So, to understand bagging, let's imagine you want to make an important decision, like whether to go for a picnic or not. You ask a group of friends for their opinions. Now, each friend has their own perspective and might mistake or be biased in their judgment. But if you take a majority vote or average their opinions, you're likely to get a more reliable and accurate decision. In bagging, we follow a similar approach. Instead of friends, we have to create multiple versions of classifier by training it on different subsets of training data. This is done using a technique called bootstrapping, where we randomly select samples from original training set, allowing some samples to appear multiple times and others not at all. Each version of classifier is trained on a different bootstrap sample, which means they have slightly different training data. Once we have different classifiers, we can make predictions on new unseen data. Each classifier independently makes its prediction and then we combine their predictions. The most common way to combine the prediction is through majority voting for classification problems. For example, we have three classifiers and two of them predict yes while one predicts no. We could take the majority vote and predict yes as a final decision. Now, bagging helps to reduce the impact of overfitting and increases the stability of the classifier. By training on different subsets of the data, each classifier focuses on different aspects and learns different patterns, which can collectively lead to a more accurate and robust final prediction. Okay, now moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. Their values will be stored in X, and for the features, and for prediction class the values will be stored in Y. X will have all the data that our user will give us as the input, and Y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7 is to 3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so now we have reached the most important part. Here we will import the bagging classifier from ensemble library and store it in a classifier variable, and we will fit the variable with the training data, that is x and y train, and we will assign a new variable y pred and will predict the value from x test using the model and store it in y pred. Now to check the accuracy, we will import metrics from sklearn, and using y-test and y-pred, we will try to calculate the accuracy. Now, since now every time y-test and y-pred value being same, the accuracy will increase, and if they are not same, the accuracy will decrease. Okay, so the accuracy for this model we have 84.4444. So now let's move to the VS Studios to get a practical look that how it works. Okay, now we have come to our Visual Studio. I have wrote this code for bagging classifier. it is as before only we have changed the classifier name here, and we have imported this classifier from ensemble library. If you hover over it, you will get all the information related to it. So I'll run on, and it will take time to connect to the kernel. Okay, so let me just tell you step by step. So we have imported pandas library here using read csv function from pandas library. We have read the iris dataset, and then from data.info we have collected all the necessary informations from the dataset, like how many values are in simple length and all these columns, and if any value is null or not null, and what is the data types. So here you can see that there are total 150 entries from 0 to 149, and data types used here are float and object. For float, that is these four, and object one, that is species. Okay, then we have separated them on the basis of features and prediction class. I have told you one another method of doing the same, so you can check those in my previous videos. Now I have assigned the values of these columns in x and the prediction class values in y. Then I have dropped the values for species. Now these are the two different methods you can follow. If you don't want to run this, you can just run this. It will do the same thing. Now from sklearn model selection we will import train test split, which I have told you it splits the data into training and testing parts. So here we can see that the training part is more and the testing part is less, as I have explained in the PPT earlier. Now from sklearn.ensemble we have important bagging classifier, and this classifier we have fit this classifier with training data, that is x train and y train, and we have stored the predicted x test predicted value on the basis of the classifier in vibrate variable. Now from sklearn we have imported matrix, and using accuracy score we have predicted the accuracy on the basis of y test and vibrate variables. So it compares the two values, and if the values are same, the accuracy increases, and if the values aren't same, the accuracy decreases. So this was it for the practical part. The same code can be applied to different data sets. It's just you have to change the name here, and if you're following this step, you have to write the columns if you know, and if you are not following this step, if you want to do it more simpler way, then you can just drop the column species column from x and then store that in y. So this was it, and now we are moving to the conclusion part. Okay, so now we have reached to our conclusion. The bagging classifier is a versatile algorithm with applications in various domains, including classification problems with high dimensional data or imbalanced classes. It offers the advantage of reducing overfitting and improving the overall accuracy by aggregating predictions from multiple classifiers trained on different subsets of data. Additionally, bagging can handle large datasets and is relatively simple to implement. However, it may suffer from increased computational complexity due to training multiple classifiers. Bagging is not suitable for problems with significant class imbalance or when interpretability is a priority, as the final prediction is a combination of individual classifier outputs rather than providing insights into the decision making process. Okay, so this was it for the video. Thank you for watching. Happy learning.